In this homework help video, I'm going to show you how we might calculate the area of a shaded region when we're only working with polynomial expressions. So for both of these pictures, you see we have some outside figure, and then we have a shape on the inside that we're going to have to subtract from the area. On your homework assignment, you have a rectangle on the outside, and you're finding the area of the shape in the middle. So what I might do is find the area of the rectangle and then subtract the area of the four triangles, because those are the values that you're given in your problem. But as a refresher, let's look at this first one. I have this area of the full rectangle, and we know that area of a rectangle is always length times width. So I can do that the area is x plus 5 times 2x plus 3, and then I am going to subtract the area of my inside figure, which is going to be x times 2x minus 4. And now we're going to have to multiply these two out. With this one, I can just use distributive property, and we get 2x squared, or minus 2x squared, plus 4x, because I'm taking that negative sign and distributing it with us. Over here, you could use FOIL, or you could use the box method to help you multiply. Some of you guys remember this. We have x plus 5 and 2x plus 3. So we get 2x squared, 10x, 3x, and 15. So this polynomial is going to be 2x squared plus 13x plus 15. And this is a very large expression for my area, because this is the big rectangle, and this is the small rectangle. And now we're just going to combine like terms. I have 2x squared minus 2x squared, so those are actually going to cancel each other out. And then we have 13x minus 4x, which is going to give me 9x plus 15. And that's going to be the way my answer ends, because I don't know the exact values of x, so it's an expression. In our second problem, we are going to have to do the area of the triangle minus the area of the rectangle. And we know area of a triangle is 1/2 base times height minus that length times width. So you notice how I'm still using the same formulas, but instead of plugging in values for base times height, I'm going to have to plug in expressions. So it's going to be 1/2 2x plus 5 times x plus 6 minus x times x plus 1. And I'm going to do this multiplication kind of off at the bottom because it is going to be a little bit complicated. Once again, I can do my box method, and I'm going to leave out the 1/2 right now. So I'm going to do 2x plus 5, and then x plus 6. So we get 2x squared, 5 times x is 5x, 6 times 2x is 12x, and 6 times 5 is 30. And when I combine those, I'm going to get 2x squared plus 17x plus 30. And then I have to do the 1/2 because I still have that 1/2 there. So I'm going to distribute that to every term. And when I distribute that to every term, I'm going to get x squared plus 17 over 2x plus 15. And yeah, this isn't perfect. Like, this isn't the prettiest answer, but that's okay. So now I can write x squared plus 17 over 2x plus 15 minus x squared minus x. Once again, those x squared terms in this case are going to cancel each other out. And then 17 halves minus 1 is equal to 15 halves. So we get 15x over 2 plus 15. So what I want you to see here is we are using some of our polynomial properties that we learned in Algebra 1, and then we're using the same strategy that we have for finding shaded regions, which is maybe make a bigger shape and then remove pieces that we can. And we just have to accept that it's not always going to be the prettiest outcome, but it will be an exact value that we could use if we could substitute in values. Thank you.